So we continue now from a China-based company to a Germany-based company. Our next speaker this afternoon is the Chief Technology Officer from Siemens. So give a warm round of applause to Dr. Bernhard Quendt. There you go.
Thank you very much for introduction, and thank you very much to be here to talk with me about the digital transformation in industry. So my name is Bernhard Quendt. I'm the CTO of the Digital Factory, and now I have the presenter also. And maybe you were asking why Digital Factory and why Siemens. So the fact is that software and communication is changing the way how in industry products are designed, conceived, and production is run. So this is a constant change and a constant transformation that we have. And I will talk and give you concrete examples on how industrial production is changed today. So industrial production faces a lot of challenges. And the main challenges for sure is velocity, is speed, is time to market. Bring your innovations as fast as possible to the market so that you are always a step ahead of your competitors. The next challenge we have is about flexibility. So a lot of products are in the so-called lot size 1, so individual products. And you don't want to have an individual production line for every individual product. So you better make sure that a lot of product variants are running and can be produced on the same production line. The next challenges our customers are facing is the challenge to improve quality, improve efficiency, and all that in a very highly secured environment to enable new business models. I don't know how firm and how much experts you are in industrial production, but I brought a lot of concrete examples and also videos so that you can imagine how industrial production looks like today and in the near future. Most important thing is that customers, and if you run industrial production, that you also face the endeavor and the opportunities of digital transformation, so that you have a clear target and a clear management decision towards a digital way to design products, to produce, and afterwards use the data of your products. This means concretely that you optimize and you organize your internal processes before, because digital transformation doesn't mean that it tidies up the mess you had before with processes, so better clean it up before you go to digitalization. This is one of the recommendations I want to give you today. And then that you start with the digitization process. Please don't wait before everything is completely available in a digital form. Just start now to digitize your processes. Start with the digitization of documents, start with the digitization of for example, production plans, production rules, and so on. And do this with the full conscience that there is not an out-of-the-box solution for digitization of production, that you need tailored, digitized solutions, and that you start now with the transformation process. Key for your competitiveness is the digitization of all steps in your value chain. This means that you digitize as well the product design, as well as the production planning, production engineering, the production itself, and service and everything that goes after the production. So for those that are not experts in industrial production, these are the main steps of the value chain: product design, production planning, production engineering, so this means the automation of the production itself, and the service. And digitization means that you have a digital twin, so a digital representation of the whole value chain, so that you can simulate, that you can experiment, that you can validate before you go to real production, because this brings speed, this prevents errors, and this gives you a whole of possibilities to play around before you go to the real and the costly production. So what we mean with digital twin is this digital representation of every value every step in the value chain, and the small animation shows what we mean with a digital twin. But let's be now very concrete, and let's look to an example what we did inside Siemens, the example of our program controller, of our Programmiergerät, which we conceived, designed, produced in a digital way. So first step is we are talking about the digital twin of the product. And the digital twin means the digital representation of the product to do simulation, to do the design for sure, the simulation and the verification of your design. And to do this in a multifaceted manner, so with mechanics, with multi-physics simulation, with electronics and with software. This is very important because if you only digitize one facet and design only one facet, this won't work. So you have to design and to simulate all facets of the product. To start with the mechanical design, this shows how, and this is not very new, I mean, we are talking about CAD systems for ages, 3D systems also, so this is about to simulate the product. The new thing is that you can, in the same system, in the same environment, design and simulate your product. So for example, if you are looking to the heat consumption of this product, you can do this with an integrated simulation in your CAD tool. And for example, here you see in this example that maybe the temperature is a little bit too high and you want to change the way you do the cooling, and you do this in an integrated way. So you use the data that you have in your design tool and you use that directly for simulation and come then to an optimized product. So here, by just shifting this a little bit, and in the next step, add some fans and cooling possibilities, you avoid the overheating of the product. And you do all this in an integrated design of your product. I'm not focusing too much on the product names. I mean, you can remember that these are our products, but I was asked to give a presentation on the principles of digitization and not a product show. Next step then is to design the electronic insides of the product. So we do this with a lately acquired software tool from Mentor Graphics, which allows you to combine mechanical design and electrical design so that you have always the overview and you have always the interdependencies between electronics and mechanics. For sure, you need simulation and validation of embedded software. And with that, with mechanics, with electronics, and with software, you have the digital twin of the product. And then comes the next step. In the integrated digital value chain, you have a lot of data already generated during the design and simulation process. And I tell you what, you don't want to introduce this data again for production planning. So in an integrated digital tool chain, you use the data for your production design. And you generate with the tools, with the software tools of the digital enterprise software suite, you design the digital representation of your production. We call it the digital twin of the production. So after the digital twin of the product follows the digital twin of the production. With the data and the specification you have from product design, you design your production. You have a lot of automation in production design, and you can use this to verify whether it fits to the requirements of your product. And I continue with, if the system let me do so, I continue with simulations for production planning. As there still important manual works also to do in production. We can simulate the environment in which people are working to prevent, for example, any accidents or to prevent fatigue. We can simulate this with our tools. For sure, we can simulate the robots that are working and the production line that is working for producing this computer. And there you can see that a lot of things like collision avoidance or optimal trajectories of the robots can fully simulate it before you build the production. And this is a real asset because you save a lot of time and you save a lot of money if you simulate before. Next step is then, after having simulated the production lines, you can simulate the whole production. You can simulate the throughput of the plant, you can simulate energy consumption, you can simulate the quality and the efficiency of your whole plant, and this is very important to know before. And you also can play around with this simulation, whether you change maybe the order of the production or you change some production lines to be more efficient. This is optimization of the production planning by means of simulation. So now imagine that as you have a lot of data transferred from the product design to production planning, you can use the data from production planning to do production engineering. So to generate the so-called PLC code. The PLC code, these are the controllers that automate the production plants. And you can generate this code out of the data that you generated during the production planning. Not all the data. Sure, you have to do some fine-tuning in the controllers, but you can use and reuse a lot of data there. You can validate. You can validate in a software-in-the-loop measure with the digital twin of our controller, or you can do that in a hardware-in-the-loop way, so with the real controller in the loop between simulation and production line. This helps you to do commissioning very efficient. And our customers save a lot of time in commissioning if they do before a virtual commissioning step. So after the digital twin of the product, the digital twin of the production, we are going now to real production. Now we are coming from the virtual world, from the digital twin, to the real production. And this is done by our world-class and world-leading product suite, like SIMATIC, like other systems, like Sinomeric, like Dynamics drive systems, HMI systems, SCADA systems, and so on. During this production, for sure, it's important to have quality check marks, and the quality has to be assured during production. This can be done with a digitized system in a very efficient way. Also, the production itself is very efficient and is safe. So with our safety systems, you're always, I would say, on the safe side of production, and you can make sure that everything that you conceived in the virtual world is working in a real world also. Siemens is very proud and is looking very carefully on security, because in an open production system with all communications and in the use of a lot of software and digitization, the risk for hacking and so on grows. So we have designed and are sticking to a charter of trust, which creates a lot of trust together with our customers. And you can be sure, if you follow this approach for digitization, you have a secure and proven product, and you can also use our consulting services for security. Because I think this is very important. In a fully digitized world, you have to pay attention to cybersecurity. Well, now, what to do with all the data that is produced by the products. So we are now in the step from real production, where the products now go to the market, and these products generate data, and you want to use this data. So this is our concept of the Internet of Things. All the things, all the production, all the products, so be it the products, be it the production line, generate data. And we use this data to further analyze and to optimize the way to produce and the way how the product is designed and conceived. The brand behind that is MindSphere. Maybe you heard about that. This is our open cloud-based IoT operating system, and there are a lot of apps and a lot of customers for MindSphere already that help to optimize the products and the production. So this is what we call the digital twin of performance, which uses the data out of the products, the data out of productions to improve further. And how to improve is shown on the next slide. We use the data from the field, we use the data from the products, and we use the data from the production lines to improve the products and to improve how to produce. And if I say we use the data, this is not very precise, because this is something the owner of the production and the product will use, but not we as Siemens. For sure, we also use data, but this is in very close agreement with the one that owns the product and the production. We will never use data which is owned by the owner of the product and the production unless this has been agreed before. And the next optimization is then, for sure, to immediately introduce changes in product design and production also to the real world, from the virtual world to the real world. So this is a kind of closed loop from the virtual world to the real world and from the real world back to the virtual world. Siemens is offering a digital enterprise suite, a complete portfolio to digitize all steps of the value chain, and we use what we sell. So we introduced all the digitization tools and methods in our own production plants, and we have more than 20 production plants inside the digital factory that were transformed to this digital world. And within Siemens also there are a couple of more production sites that use these tools. So we know about what we speak, and we have proven systems in place also to change your way to design the products and change the way how you produce. You might wonder where these software tools and various methods will be introduced and used. Well, in the full range of industrial production, the digital enterprise suite is used. So, for example, in aerospace, in automotive, in machining and electronics production, but also in food and beverage. And I will show you an example and some results of what I promised before when I started the presentation. Results on time to market, results on efficiency, and results on flexibility. So to give you an example, this is out of the branch of automotive. And automotive customers are using widely the digital enterprise software suite. So the results are very easy. So there's about a 50% reduction of development time. We have a couple of concrete examples. For example, the Maserati, the new Maserati, was developed instead of 30 months before in 16 months. So this is about 50% reduction in time to market, which is very important, as I said before, to be ahead of your competitor. Nowadays, almost all activities of robots are designed and verified and simulated before the first robot is in the production place. So this dramatically decreases and reduces the time for commissioning and starting of production. And this is an interesting figure, the last one, 99% of the possible errors in the production can be foreseen by means of simulation at least 1 week before, so that you have enough time to correct and improve your production. So with these 3 main results out of automotion, I'd like to end my presentation with a very short summary. The digital change is on the way, and the digital change is, on one hand side, an opportunity. So take benefit of all the methods that software and communication is giving to your production, but also take care of, I would say, consider that a clear management decision. So I would recommend that there's a clear management decision to transform your production to a digital one, because otherwise there's a certain risk and shortcomings also, and it's better that you have a strong will and a strong, I would say, perseverance to continue with a started digitization process. Key for competitiveness, as I said, is that you start with digitalization, but you also think that you digitize every step in your value chain, because out of the integration of all steps in the value chain comes the real value add. And, well, the digital twin is there to improve your flexibility, to improve your efficiency, your quality, and to reduce time to market. And the IoT system helps you to benefit of all the data that is generated of the products and the production, to continuously, in a sense of a closed loop, continuously improve your product and your production itself. And the last one is a clear pledge for starting the digital transformation now. It's not time to wait. Systems and the software suite is there. Start now. Thank you for your attention. Are there any questions?
Thank you. When you introduced the system, how was the response of your workforce? Did they accept it, go along with it, or was there criticism on the part of your staff?
Yeah, thank you very much for this question. For sure, there's always something that you can improve, but the main thing is that the workforce stands behind that. So what we did, that we had a very strong participation with all workers. For example, in our model factory in Amberg, which is in the northern part of Franconia, we built common project teams with the workers and the management to introduce the new way of digital methods. And this prevents that there were people that were not part of the whole transformation. And this is why I also said in the first step that it's a clear strategic management decision, which also considers and takes into account that the workforce is part of the transformation process. Thank you.
Thank you. Yes, I mean, from Siemens' point of view, so what's your expectation to the CT, communication provider, during this digital transformation?
I'm not sure whether I understood it.
What's your expectation to the telecommunication provider, like Nokia, like Huawei, like Cisco? What's your expectation to them during these digital transformations?
Yeah, there are a lot of requirements, and the requirements constantly change. So today we have field bus communication. So this is a wired communication and Ethernet communication for example, for the SCADA systems. But in future, there will be also requirements with respect to 5G. So this is something where communication plays in the future a much more much more important role also. We have industry-proven and rugged systems in the production lines for communications. So we have, and this is not too many people know this, Siemens has communication, has industry-proven communication itself as products. So, which makes sure that in a production environment where you have a lot of dust, where you have liquids and so on, where this works. So this is one of the requirements. Other requirements for sure are more the software requirements and the functionality. So it's real-time communication, which is very important. And a lot of other things like flexibility in the communication engineering. It has to be quite easy to engineer a communication network behind the production line. Thank you. Any further questions? So thank you very much once again, and start now with digital transformation. Thank you.